Unit 7, Biomechanics in Sports and Exercise Science. 7.1, Investigate acceleration and deceleration in sports and exercise science. Task 3. Acceleration. Acceleration is a measure of the change in a body's velocity over a set period of time, measured in meters per second. For example, in an 100-meter sprint at the start of the race, all the athletes accelerate, increasing their velocity over a period of time. Another example would be when throwing a javelin. At the start, when the javelin is being thrown from the athlete's hands, it accelerates, building up speed and increasing its velocity. Acceleration is a vector as it has direction and magnitude. The direction is the athlete accelerating towards the direction of the finish line. The magnitude is the velocity at which the athlete accelerates at. To calculate acceleration, it would be the object's or person's final velocity minus their initial velocity divided by time taken. For example, a sprinter running a 100-meter sprint on a track, their initial velocity would be zero as they start not moving at all, meaning they have no velocity. After accelerating, their final velocity reaches 10 and they completed the race in 10 seconds. This is calculated by taking the final velocity of 10 and then subtracting their initial velocity of 0, which equals 10. This is then divided by the time taken to run the 100 meters, which was done in 10 seconds for this athlete. So it would be 10 divided by 10, which equals to 1. So their acceleration over the 100 meters was 1 meter per second. Deceleration. Deceleration is a description of negative acceleration, or a measure of how quickly a body or object's velocity is reduced, measured in meters per second. For example, when after a sprinter running 100 meters crosses the finish line, their velocity decreases as they slow down, which is deceleration. Deceleration is a vector just like acceleration because it has direction and magnitude. To calculate deceleration, it would be the object's or person's final velocity minus their initial velocity, divided by the time taken, which is the same calculation for acceleration. For example, a sprinter running 100 meters on a track, their initial velocity would be the highest speed they are running at, as we are calculating deceleration, so their initial velocity would be 10, and they decelerate to a stop, so their final velocity is 0. You calculate the deceleration by taking the final velocity of 0 and then subtracting the initial velocity of 10, which would be minus 10. This shows negative acceleration, which is deceleration. This is then divided by the time taken, which the athlete did it in 10 seconds, so it would be minus 10 divided by 10, which is minus 1. So the acceleration was minus 1, which is deceleration. Velocity time graphs. The increase in the gradient is where the acceleration is taking place, and the decrease in the gradient is where deceleration is taking place. When the curve is below the horizontal line, that's when there's a change in direction. Inertia. Inertia is the tendency of a body to resist a change in its state of linear motion with no units of measurement. For example, a sprinter at the start of a 100-meter race has to apply force to overcome their inertia and start moving as their mass of the body is resisting to change state of motion. Inertia is a scalar as it has magnitude but no direction, as it is a tendency of a body to resist a change in state of motion, meaning it is still, so it has no direction. Inertia is proportional to mass, meaning objects with a higher mass have a larger inertia, meaning they are harder to move. For example, a bowling ball has a higher inertia than a tennis ball. This is because the bowling ball weighs around 12 kg and a tennis ball weighs 300 grams. This means that the bowling ball has a larger inertia to overcome, meaning it's going to need a higher amount of force to overcome its inertia than the tennis ball. Momentum. Momentum is a quantity of motion that a body has, or how much motion it has. For example, A sprinter has more momentum than a marathon runner, as they have a larger quantity of motion because they are going faster. Momentum is a vector, as it has magnitude, which is the velocity of the body, and direction, which is the direction the body is moving in. To calculate the momentum of the object or athlete, you would need to multiply mass by its velocity. For example, if a rugby player weighing 90 kg was running full speed, reaching a velocity of 9 meters per second, you would calculate the momentum by multiplying the mass of the player, which is 90 kg, by the velocity, which is 9 meters per second. So 90 kg times 9 is 810. So the momentum is 810 meters per second. If the rugby player was running at the same velocity but weighed 110 kg, they would be a lot harder to tackle, as they have a higher momentum, because the higher the weight, the higher the momentum.